Thank you for the introduction, Crispo. So let's start with today's session. So let me share my screen. Is my screen visible?
Yes, your screen is visible.
Okay, so let's start with today's session, and we will first of all start with this brief introduction of Excel, and we will see the evolution of Excel, that how has Excel evolved over the years. So as you can see that array formulas were first released in the Excel second version in 1987, right? And throughout these years, as you can see that the major change that happened in Excel, the calculation engine of Excel, that was in the year 2019, right, when Excel 365 version was launched, and in that dynamic arrays were released. After dynamic arrays were released, few functions were released. When dynamic arrays was first released, that is sequence, filter, sort by, etc. But the major breakthrough happened when lambda functions and the other lambda helper functions were released. So that enabled the functional programming in Excel. Earlier, it was not possible for us to create our own functions in Excel, but after the release of lambda functions, lambda helper functions, it is now possible to create our own functions without the need of VBA or any other that sort of thing. We can directly create our own functions inside Excel itself. And this is all that we are going to see today, that how we can use lambda helper functions and lambda for solving few problems that include the use of loops, right? So next we will see that what is the meaning of loops and what are the different kinds of loops that we have. So let's move on. And this is about loops, that loops in programming are like doing something again and again until you decide to stop. So loops means that we are carrying out the same action and again without interruption. We are telling the machine that you do this particular action, and we also set up a condition that you do it this many times, or we set a stop condition, right, that you do it until here, and after that, if that condition is met, you stop the loop. So it's like telling a robot to perform a task repeatedly until you say that's enough, you stop working, right? So there are mainly two kinds of loops, that is for loop and while loop. For loop means that you tell the robot how many times to do the task. So it's like saying that we wish to make 200 cookies. So there is some finite number that, okay, we wish to make 200 cookies. There is some limit. So we can tell the robot that, okay, you make 200 cookies and stop after that. So that's a condition here, make 200 cookies. And what is the use of while loop? So for loop contains for each loop and for next loop. We will see them one by one in the following slides. While what does while loop mean? That you tell the robot to keep doing the task as long as a specific condition is true, like saying keep baking cookies until you run out of cookie dough. So this does not contain a finite number that make 200 cookies or make 400 cookies. We keep on making the cookies until our dough is over, right? The dough that we are using for making cookies. So that can be anything, right? We can make any cookie, any number of cookies out of that. It can be less than 200, equals to 200, or it can be more than 200 as well. So there is a condition, right? There is a condition attached that we wish to continue until that condition. So let's move on. This was a brief introduction about loops. Let's move on to the main part now. That is, we will start with for each loop. Now, what does for each loop means? In for each, we will just see this and we will try to understand this in detail when we will start covering the functions. For these 3 pointers have to be kept in mind. For each row, column, value, etc. That we will perform a common action, right? We will perform a common action for each of the rows, for each of the columns, or for each of the values. First point is this. Second point is that when we are performing this action for each of the rows, columns, or values, we will not skip anything. We are not going to skip, let's say, the second row or the third row. We cannot skip any particular row or value. We will perform that common action for each of the rows or column or values. Second point is this. The third point is that the size of the output array cannot be altered. So this means that if, let's say, we have the array of size, input array of size, let's say 10 rows and 20 columns, then the final output will be of either one row, 20 columns, one column, 20 rows, or 10 rows, 20 columns. That will be the thing. We will see that with illustrations, but these 3 points have to be kept in mind. We will illustrate each of these 3 points in the upcoming slides. So let's start with the first lambda helper function, that is by call function, right? By call. Now with the name itself, it is clear that what does it do? It performs a common action for each of these columns, for each of the columns that we have in this array, let's say, right? This is our array of values, array of sales that we made in each of the years, and these are by divisions, right? These are split by divisions, by division and by year as well. So these are the sales values. And by call means that we have to perform a common action for each of the columns, right? So let's say this is our array, and the size of this array is, this is these are how many columns? 7 columns. And how many rows? 5 rows. So 5 rows and 7 columns, right? Now our task is, let's say that we wish to calculate the average sales by year, right? So for example, for 2016 we wish to calculate the average sales. So first, one thing is common across all the lambda helper functions is, or across all these loops that we are going to discuss, that we will have a common action for each of the row or each of the column or each of the value. We will have one common action. Here the common action is that we wish to, let's say, perform the average of these values, the average of these values as well, the average of these values as well, the average of these as well, and so on, right? So what we will do equals to average. Earlier what we used to do before Excel 365, we used to select this, right? Select these values, let's press enter. So we have got result here as 769. Now if we wish to calculate the average for each of these years, we used to drag this across, right? We used to drag this across, and we now have the average calculated for each of these years. Now in Excel 365, with the entrance of lambda helper functions, this can be made dynamic. So let's say this is going to be our array, right? Array of values. Now for each of the columns we have to perform the average. So this is our, so view formula var, right? So this is our common action that we have to perform average. Now what we will do, we will say that we have to do this action for each of the columns. So we will call by call function, and again we can read its description as well. Applies a lambda function to each column, right? Focus on this word, each column. Array is let's say our array is this of size, again 5 rows and 7 columns, comma. Now we will start writing our function. So our function will be, the style of writing the function is lambda open the bracket, right? And then it is asking for a parameter. Here in by call we have to pass one parameter. So that parameter is for each of the columns, right? Let's say this column, again let's say first column, then second column, then third column, and so on. So we are calling that out by, let's say, x. That x denotes each of the columns in that array, comma. For each of the columns in that array, right? For each of the columns x in this array, what common action do we have to perform? We have to perform the average. So earlier we did this task for, let's say, this single column. We will replace this by x, right? We will replace this by x. Let's close the bracket. Let's again close the bracket. So what it will do, it will perform the average for each of the columns in this array. Let's press enter, and we have got the result, right? Again similar to the previous one, but now the magic here that happened is that we don't have to drag across the formula. We don't have to drag it across, right? It is all spilled. So we have the result for each of the columns corresponding to that column, right? And again the formula in the corresponding cells, these many cells, these are grayed out, right? We cannot edit the formula here. We can only edit the formula in this single cell where we have applied the formula. Now this point is clear, right? For each row column value, that is, let's say this is our array, and for this array, for each of the columns we have to perform this common action, correct? This first point is clear. Then we don't skip anything. What does this mean? Tell me that how many columns does this array contain? 7 columns. And what is the size of our output? What is the size of our output? It is again 7. Count is 7 here, right? So we cannot have output as, let's say, 6 columns or 8 columns or 9 columns. The number of columns will be exactly same as the input array that we have given here, right, inside our by call parameter. So this is one point, that the output cannot be altered, right? We first of all, we don't skip anything, and the size of output cannot be altered. We have not skipped any single column. We have done for each of the columns that are contained here. We have not skipped any column. So these are the points that have to be kept in mind. This was first example with by call. Let's move on. Let's move on to the next example, by call 2. And here we have to do missing value imputation. Now what does it mean? Let's say this is our array, input array, right? Input array of values, and in this we have some blanks here, right? As you can see here that this is empty cell here, this is again empty, this again doesn't contain any value. So these are highlighted as well using background color. And what we wish to do is, let's say in this column these two are empty cells. Now what we wish to do equals to, let's say we calculate the average of the first column. Let's say we calculate the average of this column. We got it as 661. So wherever there are any blank cells, we wish to replace those blanks with this number 661, right? And let's say for the second column, we wish to replace the blanks with the average of the second column. So for the second column we will replace the blanks with 643, and for the third column we will replace it with by the average of the third column, right? This is our task. So first of all, what we will do, we will calculate the average of all the three columns, right? Let's say we calculate it here, and as we saw in the previous example that we will use by call function in order to perform average by column here, right? So again, this is our common action across all the columns, one common action that we have to perform for each of the columns in the input array. So we will use by call function here, and this will be our array here, right? Comma lambda, open the bracket. We are denoting, let's say, each of the columns by, this time let's say col, column, right? Each of the columns by col. This is a variable, you can change it anytime, right? Now column, average of each of the columns. So we will now do average of each of the columns. So we will use the variable col here, right? And you can see here that the rest of the options that the IntelliSense is prompting us to have that fx symbol here, right? Fx symbol here. Fx stands for the function. Here you can see that this call, against this call, this symbol of x denotes the variable that we are using. So this call is a variable here inside by call. So that's why we have symbol of x here, right? Symbol of x. Let's close the brackets. Let's press enter. So we have got the average by column. For each of the columns we have got the average. Now the next task is that we have to replace these blanks with these corresponding averages. So we can do it simply, equals to if. So first of all, let's evaluate that what are the which cells are blanks here in this array. So what we will do here, we will evaluate it using this range equals to, let's say, an empty string. So we got this array of trues and false, right? You can see here we got true here, we got true here against this blank, we got true here against this blank. So we have written this condition here. Now our next task is using if condition. So if these values are true, then from where do we want the values? We want the values from this array, right? This array of averages by column. Else we want the result back from this original input array only. Let's press enter, and we have got the result that we expected, that we have replaced the blanks with the average of that column. So this was the task, and the principle that works here is broadcasting, that the size of this array is, let's say, 3 columns and 10 rows, and the size of this is again 3 columns and 1 row. So this will broadcast the result, right? This will broadcast the result. It will make the size of this particular array and this array, right, C7 to E16, it will make them equal virtually. This has a working which I probably will show someday later, but the principle that is working here is broadcasting, right? Broadcasting. So this is how it works, and we can again simply copy this, right? We can copy this and directly paste this formula here, and we can remove this as well. So this works like this. And again, we can see that the size of output is 3 columns here, and again for each condition remains intact here, that for that the size of the output cannot be altered. So we have not escaped any column here. So let's move on to the next example, that is by row. And again, by row is just as similar to by call. Here the just the change is that we are performing a common action. Focus on this word, a common action, common function on each of these rows. So previously we calculated the average for each of these years. Now we will calculate the average for each of these divisions. So what we will do, we will again similarly use by row. By row, this is our array, comma, lambda, open the bracket, and let's say we denote each of the rows by r. Each of the rows by r. And what is the common action that we are going to perform? The average, right? Average of each rows. Focus on this, the average of each rows. We are not skipping any rows. So average of each, we will use the r variable here, right? Let's close the brackets. So it has a problem here that it changes the symbol here. Let's close the bracket, let's press enter, and we have calculated the average for each of these divisions. So this is how by row works, that for each of these rows, let's say for this row, then this row, then this row, it is performing the average, right? This is the illustration of by row. Let's move on, and let's see this example of by row as well. Now the task here is that let's say we have this table, and from this table we wish to select only those rows which have no empty cells, right? So let's say this has no empty cells. This has a blank cell, right? This has a blank cell here. So we will not select this. This again has many blanks, so we will not select this. This has no blanks, so we will select this. So this is the task that we have here, that we have to select only those rows from this table which have no blanks, which contain all the all the 6 columns, right? Which contains all the 6 columns. So let's see how we can do that. First of all, what we will do, that for each of the rows we will check that how many blanks do they contain, or do they contain any blanks or not. So we will do that first. So if we have to check that, what we can do is we can use equals to, let's say we do it like this, like equals this. Let's say this particular row is equal to an empty string or not. So we got our values as trues and false. Now we wish to select this particular row, right? We wish to select this particular row, and what we have got here is all we have got all false here. Let's drag this down. Here we have got at least one true. Here we have got, let's say, three trues. So we wish to select only those rows. We wish to select only those rows which don't contain any true, which don't contain any true. So what can we do here is we can use or condition here. So or, and we got here false, right? We got false here. And let's say we will use not here in order to convert this false to true, right? Inverse of false is true. So we converted this to true. We have to include this row. Yes, we have to include. So we got true here. Do we have to include this row? No. So we got false here. This row, because it contains false, we don't have to include false. Again, true for this particular row, because we have to include, because it doesn't contain any blanks here, right? So this is the this will be the criteria for filter. Now what we are going to do, that let's say we are performing this particular action for this row. We are performing this action for this row. We have to do this for each of these rows in this data. Each of these rows in this data. So again, we will use by row function. By row, and this will be our array, comma. We will again write lambda function, lambda x. This by x. Let's close the brackets. Let's press enter. So we got this array of trues and false. And now what we will do here, equals to filter this on the basis of this criteria, right? So we got the result here. We have only got those rows where all the columns are filled. So let's try this out. Let's try this out. Let's say we fill the third row completely, and we have got again the third row as well included in this result. So this is how this works. And again, as you can see here, the result of by row, in this, the number of rows that we have here is equal to the number of rows that we have here, right? The number of rows is equal to the number of rows that we have here. And one more point here is that we will have to perform some sort of aggregation thing here. So we performed, let's say, or condition here. we cannot pass an array inside an array. So that will not work here inside by row. That will not work here. Uh, right, we cannot say, like, let's say if I remove this or part and I only continue with this x equals to this, so this generated an array of 6 columns and 1 row. That will not work here. This will prompt a calc error, and nested arrays are not supported here. That's why it is giving us this prompt. So this will not work here. We will have to use some sort of aggregation here inside by row, by call, map, these sort of functions. Correct. So we will see that as well, that how does it work in upcoming slides. So this was illustration of by row function. Let's move on and continue with map function. So map function again, in by call we saw that we are going to perform that common action, common task on each of the columns in this array. In by row we saw that we are going to perform that common action, this common action for each of these rows in this array, right? Now in map we are performing a common action on each of the values. So this is a separate value, this is a separate value, each of the cells or values, you can say anything, but we are performing the common action on each of the values here, right? Each of the values here. So let's see that what is the common action here. The divisions, and let's say the cost for project A is 290 and 87. There may be some criteria that they have listed out using delimiters here. Now our task is to, let's say, sum up these values for each of these cells here, right? By split, first of all we will split them and then we will add them together. So let's say for project A and HR, what we have to do, first of all we have to use text split here, right? Text split, this is going to be a text, and let's say our row delimiter is a comma here, right? Comma and a space here. Let's close the bracket, let's press enter. So we have got the result here that 290 and 87 are split into different rows here. Now we will multiply this by 1 as well in order to convert these text values to numbers. So we have converted these to numbers, and then we can use sum function here. We will use sum function here in order to add them together. So we have the result here 377, which is the sum total of 200 plus 90 plus 87. Now we have performed this task for, let's say, project A HR. We wish to do it for, let's say, project A finance, project A sales, right? We wish to do it for each of these combinations, right? Project B HR and so on. So we wish to do it for each of the values or each of the cells that we have in this array. So what we can do here is this C6 represents each of the cells in this array. So we will replace this by a variable that we are going to generate inside map function. So declare inside map function. So we will use map function here, and we will read its description as well. Returns an array found by mapping each value. Focus on this word, each value, right? In by call it was each column, in by row it was each row, and in map function it is each value. Each value in the arrays, right? We can pass multiple arrays as well inside map function, but we cannot do so inside by row or by call. In the arrays to a new value by applying a lambda to create a new value, right? So this is the transformation that we are going to do, right? This is the transformation, this is the task that we are going to perform. Map function, and our array will be this array, comma, lambda, and let's say we call each of the values by v, and we will replace this C6 by v. Okay, let's close the brackets, let's press enter, and we have performed the again the common task for each of the values here. And why we got the value error for this particular combination? Because we haven't specified the delimiter as a question mark here, right? We only gave the delimiter as comma and a space only. So we will use an array here, array of delimiters. We can pass multiple delimiters as well inside text split function. So we will pass multiple delimiters here. Our first delimiter was comma and a space. Our second delimiter will be a question mark and a space. Okay, let's close the curly bracket here, let's press enter, and we have got the correct result for this as well. So this is how map function works. And again, for by call it is each column, for by row it is each row. For each row we are not skipping anything, we are not skipping any row here. we are not skipping any value here in map function. As you can see that the size is equal to the size of the input array in case of map, right? We will do the comparison at the end as well in the summary sheet. So let's move on. And this was for each loop, and we saw each of these points as well, that we don't skip anything. Size of the output array cannot be altered, and for each row, column, or value, we are performing the common action. Let's move on and let's continue with the for next loop. Now in for next loop, we use a supporting sequence to refer to each to specific row, column or value. We can skip or reorder output. This is second point. And the third point is that the size of the output can be altered. So let's see this with the help of an illustration. So for this, for understanding this, we will use this particular example, and we will see the application of reduce function here. So let's say we have this table here which contains the fruit names. This is fruit 1, this is fruit 3, and this fruit 2 is empty. Again, here all three are filled. Here these two are blanks here. Now our task here is to fill to right, fill to left, fill to left, right, fill to left. Our task here is to fill to left. Now, what does this mean? That let's say here if we have apple, then in the second column we want mango here. We want to shift the values, not fill. We wish to shift to left, right? Shift to left. Shift to left, right? Then mango here. Mango here. Then for the second column, let's say this is fine. We don't want to shift anything. So this will be as it is. Grapes, banana, and orange. Now for the third column, grapes will be here, and then following two columns will be empty. This is the task that we have to perform here. Now, by row cannot be used here. Why by row cannot be used here? Because if we see by row, this is the input. This is the input, and this is the output. What is the size of this output? It is only single column. And what is this? In the input array, how many columns did we have? We had 7 columns, but the size of the output is only a single column. So if we see here, what will be the size of the output? It may be 3, or it can be less than 3 as well, right? It can be 1 as well, it can be 2 as well, it can be 3 as well. Not greater than 3, but it can be less than or equal to 3, right? It can be less than or equal to 3. So we cannot use by row here, because in case of by row, the size of output is always a single column. The size of the output is always a single column, and the number of rows that we have in the input array, as we can see here. So we cannot use by row here for sure. We cannot use by call as well, because we don't have to perform any action by columns. For each of these columns, we don't have to perform any action. We don't have to shift up. We have to shift to left. So by call, there is no chance for by call. And then we cannot use map as well, because in case of map, again, what we have to do is we have to perform the action for each of these values. Here we don't have to consider each of these values individually. We have to consider the row as a whole, right? Each of these rows as a whole. For each of these rows, we have to perform some action. So by call is eliminated, by row is eliminated, and map is eliminated. Now what is the option that we are left with? The option that we are left with is reduce, because reduce has a very special property against all the other lambda helper functions. We will see that towards the end, but how we can use reduce here, we will see that. So first of all, what we have to do for each of the rows, we will specify that. So equals to, what we have to do, we have to use 2 row here, right? 2 row, and let's say this particular row is our array, right? And we have to ignore blanks from this. So we will use 1 as our input here, as our argument here, and let's close the bracket. We got grapes here. Let's change our input to, let's say, this particular row. So we got this result, and again this blank is omitted here. Let's change our input to, let's say, this first row. So we got this as a result. Apple and mango are together, and this blank is eliminated from this. Now we have to perform this action for each of these rows. We have to perform this function 2 row for each of these rows, and we have to consolidate the result together, right? One under the other. Again, here we are dragging the values down here, right? we are dragging the result here, but we don't want dragging here in this Excel 365 version. So what we can do here, we can use reduce function. Now how we can use reduce function? Let's say we wish to perform this two row function for each of these rows, right? For each of these rows. Now what we can do here, we can refer this array. Let's say let's say we use reduce function here, reduce function, and let's say our initial value is an empty string. Our array is this array. We cannot use this array, I will explain that. We cannot use this array, and let's write our lambda function. So inside reduce function we have two parameters, that is the previous result stored, and the current value. The array that we passed here, we will loop through each of these values that we have in this array, right? It will first pick up, let's say, this value, then this value, then this value, then this value, then this value. And what it will do, lambda, we are denoting the previous result by, let's say, x, and the current value, that is each of the values in this array by y, right? And let's say what we are doing two row for y. Now why reduce cannot be used directly here like this? Because we got melon here only in result. Why? Because what is reduce? Reduce is again similar to map. What is map doing? It loops through each of these values. It will do this for this value, common action for this value, then this value, then this value. Map is all, reduce is also similar. Reduce and scan both are similar, right? Reduce and scan both are similar. They will perform the action for each of the values. They will perform the action for each of the values, not each of the rows or columns. So we will have to find a workaround in order to deal with each of the rows here. So how we can do that? So let me remove this reduce function here for now, right? And in place of this y, we will select this row. We got apple and mango here. Now uh, what is the row position of this particular row, right? This particular row in this array, in this table, what is the position of this row? It is number one. This is the first row of the table. This is the second row of the table. This is the third row of the table. So what we can do here, we can use a function here, choose rows, choose rows. We will select from this array. This is going to be our input array, comma, let's say first row, right? First row. Let's press enter and we got the result here. We wish to do this for, let's say, third row. So we got grapes here, right? This was the third row. Let's say we wish to do this for fifth row. So we got our result for fifth row. Let's say what is the row number here? 1, 2, 3, 4, 5, 6, 7, 8. We have got 8 rows here. So let's say we do this for eighth row. We will get the result corresponding to eighth row. If we do this for, let's say, ninth row, we will get value error because there is no ninth row in this result. So what is our limit? That we have to perform this action for each of the rows. First for the first row, then second row, then third row, fourth row, and so on until ninth row. So is there any finite condition that we have to perform this action only these many times? Yes, there is a finite number that we have to perform this action only 8 times for the first row, second row, and until ninth row. So this is the condition here, that we have to perform this only 9 times. Now, sorry, 8 times, right? 8 times. So our loop is fixed, that we have to use for next loop. Why for next loop? Because we cannot directly use this array here. Can we use this array directly here? We saw we cannot use this array directly here because we don't have to loop through each of the values here. We have to loop through each of the rows here, and we cannot use by row, by call, or map function. So we have to loop through each of the each of the rows, and we have to make a use of this supporting function, that is choose rows, and inside this we have to input these numbers as well. So we are looping through each of the numbers here, sequence of 8 here. So what we will do here, we will create a sequence of, now how we arrived at the number 8? Number 8 is the number of rows that we have in this array. So let's close the bracket, let's press enter, and we got the result here as the sequence of 8, 1 to 8, right? And what we have to do, that we have to generate result corresponding to each of these row numbers, each of these row numbers. So let's say in place of this, let's say I do this for third row. So I got result for third row here, right? Now we cannot do this using by row, right? We cannot do this using by row because again, if I choose, let's say, second column, a second row, so this has multiple columns here. But in by row, in case of by row, we saw here that we cannot use an array here. We cannot use something here that will generate multiple columns or multiple rows. So inside by row, we cannot use that, right? So by row is not an option here. We cannot do this using by row, that for each of these rows do this action. We cannot use map here as well, because again, the problem with map is that arrays of arrays are not supported. So what we will do here, we will use reduce, and along with that we will use another function, that is vstack. So why does that combination works? So if we see here, let's say, what does reduce do? Reduce loop through each of these values. Reduce will loop through each of these numbers, and at last it will give the result for 8th row. So let's do it here. Let's say we use reduce function. Reduce, our initial value is, let's say, an empty string, right? And our array is now this array of numbers. So that is why the name here, for net array. Have to use this supportive sequence here for each of these numbers in this array, and lambda, we are denoting the previous result by x and the current value by y. Now what is stored in this y? 1 2 3 4 5 6 7 8, so on, right? These numbers are stored in y variable, and in empty string. For the second iteration, when the value of y is 2, what will be the previous result? The previous result will be the result of uh, the result of this for the previous iteration, that is for y equals to 1. So we will see that as well. What we will do, we will replace this g7 by y here, because each of the numbers are stored in this y variable. We will close the brackets here. Let's press enter, and we got the result for the final value here, that is 8, right? 8th row. We got the result for this particular row, guava and melon stacked together. Now this is only generating the result for the last row. We have to generate the result for each of these rows. So what we can do here, that, let's say, now let's say at this iteration, at second iteration, what, let's say at 8th iteration, what will be stored in x? What will be stored in x? In x, the result will in x, it will be y equals to, let's say, 7. Lychee and guava. Lychee and guava will be stored in x for y equals to 8. So for each of these values, what is stored in y? Each of the numbers 1 2 3 4 5 6 7 8, and in x, the result, and in x, what is stored? The previous result, the result for the previous iteration, right? So what we will do here, we will use vstack here, vstack, and we will stack the previous result, that is x, with the current result. This is the current result for, let's say, each of these row numbers, and let's close the brackets here. Let's press enter, and we have got the result here, right? We have got the result here, that with each of the previous results, we are stacking the current results. With this just one change, we got the result here successfully, and we don't want these NA errors here, right? We don't want these NAs here, so we can use if NA here. If NA, if there is any NA errors, we want an empty string, so we have got rid of those NA errors. And now what is this first empty row, right? These all are empty strings. So what is this? This is because of this empty string, right? Because our initial value was this empty string. If we, let's say, give 1 2 3 here, so we will get 1 2 3 here, right? Whatever we give here, we will get the result accordingly, because we are stacking the previous result with the current result. Now let's say we can use this initial value smartly here. What we can do here, we can use this as our initial value that we wish to stack with the headers, the result for each of the rows, right? Let's press enter, and we have got a result here. Correct. And let's copy the formatting as well and apply it here. So we got the result here for each of these rows. Now, how can we alter the size of output? If, let's say, we divide the number of rows by 2, so we got the sequence of 4. We are performing this action only for the first 4 rows. We are performing this action only for the first 4 rows. Or let's say, in place of this sequence, we use rand array function, right? Equals to rand array, and we are generating, let's say, 5 rows and only single column. Minimum is, let's say, 1 and maximum is 8, and we wish to generate integers. So we will get random results here, right? Random results here for random rows. So this is how we can alter. This is how we can alter the size of output here. That if we use, let's say, for next loop, then we can say that we wish to do this action for third row, sixth row, second row, fourth row, eighth row, in any order, right? We can reorder as well. As you can see, we can skip. We have skipped, let's say, first row here, fourth row here. We can skip here, and we can reorder as well. And the most important point for next loop was that we are using a supporting sequence here in order to select specific row, column, or value here. We cannot directly use the input array here. So this was the condition here. And thirdly, that size of the output array can be altered. So here the size of the output is altered, and this has no pattern. That is, this has no pattern that, let's say, if this has 3 columns, so this can have, let's say, 3 columns or 2 columns or 1 column as well, because it depends on the number of blanks that we have in each of the rows, right? So this was the example of for next loop, that we are looping through each of the values in this sequence. So again, let's change this to sequence of number of rows that we have in this table, right? So we got result for each of these rows, and similarly we can do some action for each of the columns, each of the values, and so on. Okay, so let's continue with the next loop. So let's summarize all these things that we have done until here. So let's see here that what is the size of the input for each of these functions. Size of the input is number of rows and number of columns in the input array, right? Let's say here we have or here we have 7 columns and 5 rows, and this is the output. This is the input for by row, and this is the output of by row. So in summary, we can see here that, let's say, size of the input is r rows and c columns. The size of the output will be r rows, the number of rows that we have in the input, multiplied by the output, multiplied by 1, right? Means 1 column. Here we have r columns, r rows and c columns. Here we have only 1 row and c columns in the input column, right? Map, it is same. Size of the input and size of the output will be exactly same. In case of scan as well, it will be exactly same. In case of make array as well, size of the input, and it doesn't matter here actually, right? This doesn't fit a case, right? Because um, we are ourselves making some input values here, so it doesn't matter in case of make array. In case of reduce, why reduce is so special? Because if the size of the input is, let's say, r by c, output can be of any number, right? Output can be of any size, output can be of any dimension, of any rows and any columns. Let's say for we did this task here. What we will do here, let's say we will use reduce function here in similar fashion, reduce, and we have to loop through each of these values here. So we will use an empty string here as initial value. We have to loop through each of these values here using reduce function, comma, what is the function that we are using? Lambda x comma y, right? Previous result and the current value. And for each of the current values, what we are doing, we are splitting the y, right? Each of these values y, and row delimiter, let's say we use this as comma and a space, and question mark and a space, right? Let's close the curly bracket here. Let's close the brackets. Let's press enter. We got this result for this last value, right? It looped through each of these values and we got the result for this last value. Now what we will do here, we will use vstack function here. Vstack x with this current result. Let's press enter. So we have split each of these values one under the other, right? One under the other. We got each of these values one under the other, and we can drop the first row because this is not required. So we will use drop function here, and we can drop the first row here, right? So we got this, and we can, let's say, calculate the total from this, and we will have to multiply this by 1 in order to convert this to numbers. So we can calculate the total cost from here for the whole organization, right? So we can use reduce like this as well. So size of the reduce can be anything, right? Size of the output in case of reduce can be anything, any rows and any columns. Let's move on and let's cover do until loop now. Do until loop, and in case of do until loop, as we saw earlier as well, that we need a base condition to stop. When we saw the example, that the base condition was that when the cookie dow gets over, we will stop making the cookies, right? So we need to give a base condition here. And here if we have to use, let's say, uh, do until loop inside using functions inside Excel, then we will have to use the concept of recursion here, recursive lambda here. So we will understand recursion. Again, very basic example. Recursion can be quite complicated as well, but we will see a very simple example for now, right? This you can consider it just as an introduction to recursion. So let's say what our task here is, we have to again do recursion, and we will see two ways of defining our recursive lambda here. One inside advanced formula environment, so we will also see an introduction to advanced formula environment, and one using directly inside let function. So we will see two different versions here. So let's say we have this number here, right? We have this number here, and we have to keep on adding the digits of this number until a single digit number is obtained, right? This is our task here. We have to keep on adding the numbers, the digits of this number until a single digit number is obtained. So let's say if we have to add the digits of this particular number, so how we can do that? How we can do that? We have to do, let's say, 8 plus 4 plus 7 plus 3 plus 8 plus 3. This is the task that we have to do. Now, how we can do that? First of all, we will split the digits into multiple rows. So we will use mid function here. This is going to be a text, comma. What will be the start number? Let's say sequence of len of this. That is, let's say for the first time, this is again another loop, another kind of loop, but not in real sense. For each of the numbers, let's say 1, 2, 3, 4, 5, 6, 7, 8, the length of this number, we will we will keep that particular digit, right? We will see that length, common number of characters is 1 here. Now, how this is working? What does the sequence contain? 1, 2, 3, 4, 5, 6. Now for each of these numbers 1, 2, 3, 4, 5, 6, we are picking up that particular digit of that index. First digit, then second digit, then third digit, and so on. So we are doing that. And now after we have split these digits into multiple rows, we will multiply these by 1 in order to convert them to numbers. And then we will use sum function here, sum these digits together. So we got 33 as our result. Now, is our condition fulfilled? Is this a single digit number? The answer is no, right? This is not a single digit number. These are two digits, 3 and 3. So we will keep doing this. We will keep repeating this process until a single digit number is obtained. So we'll now do the same action, right? This same function we will perform for 33 now. So we will drag this down, and we got a result as 6 here. Right now 6 is a single digit number, so we will stop and we will keep the output as 6 here. Right, a single digit number is obtained, so we'll stop here, and we will keep this as our output. So now let's say we change this number to something else. We got this something else. So now in this case, as you can see, this is a 2-digit number, right? 55 is a 2-digit number. 10 is again a 2-digit number. So we will continue the loop now. We will not stop here. We will continue. We will continue next, and we will take this as a result, and we will we got this as our output, right? One is a single digit number. So we will stop here, and we will say that okay, this is our output, and you stop here because our condition is fulfilled. So there is a base condition that we have to fulfill. Uh, and until that condition is not fulfilled, we will keep on performing this particular action. That is, we will first of all split the digits, then add them together, right? We will keep on performing that action. So let's see how we can use this inside functions. And again, the meaning of recursion, the actual meaning of recursion is calling a function inside itself multiple times, right? Calling a function inside itself multiple times. Now what does it mean? Let's say we are performing this action for this input number here, right? Let's copy this and Let's paste it here, and let's use a let for defining our variable, because we are using this b6 two times, right? So we will define this inside let and num, right? Num as, let's say, b6 comma, and we will replace this b6 by that num variable, num, and again this b6 by that num variable. Okay, let's close the bracket, and we got 55 as a result. Now next time, if we, let's say, drag this down, we are doing this for this 55. So what we will do here, we will copy this here, this function here, we will come here, and what we are doing here is, in place of this b7, we are again pasting that same function. Okay, we are again pasting the same function, we are calling a function inside itself, we are again pasting the same formula here, so we are calling a function inside itself, right? We again, let's say, drag this down, we will copy the previous result and use that as our input here. That will be our input here. So we are again and again calling the same function inside itself, right? We called the same functions. Base function was this one, sum and mid, right? We are calling that again and again inside itself until this particular condition is satisfied. So this is what we are doing. And our base condition is, what is our base condition? That the length of the number is equal to 1. So here the length of the number is equal to 1. So our base condition is fulfilled, we will stop. What is the base function? Base function is this one, sum and mid, right? First we are splitting and then we are adding those digits together. So this is the base function. Now using these two things, base condition and base function is just similar as what we saw earlier, that this was a common action that we were performing. This was the common action, right? This was the common action. So base function is just similar like this, that we are performing this common action. Just the added condition here is that we have a base condition here as well. Okay, so we are calling a function inside itself, and we have a base condition, base function. So using these three things, we will create our lambda recursive lambda function for this thing. So for that, what we will do, we will go to home tab, and now we have advanced formula environment inside Excel Labs, right? So we will open Excel Labs, and here we will define our formula. Right here we can define our formulas. So we will click on this add name button, and let's say we wish to name our function as some digits, right? Some digits. And now we can give a description here as well. Digits of a number until a single digit number is obtained, right? This is our description for this function. And now we, so when we are defining our lambda function, what we will do, we will use here lambda, and what is the input that we are going to take? We are going to take a number, so we will uh, call out that as num, like num. And what we are doing with that num, what is the base function that we were performing? It was, first of all, we were splitting that, so we used mid function, mid of num. Again, the num is the input that the user will pass, num comma start number is, let's say, sequence of len of, again, num here, right? And comma number of characters was 1. So this was the part where we split the number into different rows, and then we multiplied this by 1, and then we added these, used some function here. So we used some function here, and this is our base function, right? This is our base function. Now in order to keep on calling this again and again, we have to add a condition here. And again call this sum digits function. What is this sum digits function doing? It is adding the digits of a number, input number, right? So what we will do here, let's say we click on done, and let's save this, and let's say we call equals to sum digits function, sum digits, and again you can see this fx here, fx symbol here, and this description that we added here. Fx denotes that this is a function now. This is the function that we have created on our own. This is not inbuilt. We have created on our own. So num, this will be our input number, close the bracket, and we got 55 as a result. Let's say we drag this down, we got 10 as a result. 10, and for this input is 55. So we are again calling what we are doing. What we are doing that if we copy this sum digits function and we paste it here, we will get the result, right? If we again drag this down, we got 1 here. If we paste the previous, if we copy the previous formula and if we paste it here inside B7, we will get 1 as answer, right? We will get 1 as output. So what we are doing, we are calling function inside itself, function inside itself multiple times. How many times we are calling it? We are calling it 4 times. So we are calling the same function inside itself multiple times. This is the meaning of recursion. We have to add base condition. We have already added the base function. So we have done everything inside this, just that we have to add the base condition as well. So we have created this function and we are calling it again and again. But this doesn't look elegant and we don't know that at which iteration we have to stop. Let's say this might continue until, let's say, 5th iteration as well. We are doing the same we are performing the same function for 5 times and we didn't got a single digit number. So this can happen. So this is not an ideal way. So that's why we will use lambda recursion here. So what we will do here, we will again go to home tab, Excel labs, and we will edit this function that we created here. Right now, what we will do here, we will first of all add a base condition that if the length of number is equal to 1, right? If it is a single digit number, then what we want that number back, right? We want that number back. Let's say in this case 1 back, the example that we saw, we want the number back. Else what we want, we wish to continue the process, we wish to call this same function again and again, right? So we will again and again keep on calling sum digits function. Sum digits function, we will keep on calling it sum digits, and this was the base condition, right? And let's close the brackets here. Right, let's close the brackets here. So if the length of the number is equal to 1, then we want that number back. Else we are calling that sum digits function again and again. We saw that function inside itself, and this is the base action that we are performing, and this is how recursion will work. So let's click on done and let's save it. This is just for illustration that we saw. Now let's use sum digits now, sum digits function now. So we will use this as a number, and let's close the bracket. We got directly we got the input directly as 1 here, right? We got the input directly as 1 here. Why? Because it directly performed the recursion, it directly fulfilled all those conditions and gave us this as our output, right? Directly this as our output. Let's say we change this to this number, so we got directly here 8. We got 8 directly here. Let's change this to some another number. We got directly 1 here. Okay. Okay, so this is how it works, and this was just for illustration. Now this sum digits is not the earlier one. This is now recursive. Sum digits is now recursive. So this is just for illustration purpose, right? I will just add this here. Right, this is just for illustration purpose now. This has got nothing to do with this part, right? So this is how recursion works. This is how do until loop works, that we add a base condition here, that where do we have to stop. So we saw this using AFE, right? Advanced Formula Environment equals to sum digits, and again we can see that we have this description as well, sum digits, and our input number is, let's say, this. We got 6 here, and we can define our recursive lambda function inside let function as well. How we can do that? Very simple. What we can do, we will go to home tab again, Excel labs, and we will copy this entire formula, right? We will copy the exactly same. We will come here and we will use equals to let function, and inside this we will create our own function, right? Some digits, the function name that we gave earlier, we will use that exactly same here, some digits. And let's say we add recursive as well, right? Recursive, right? This is going to be our function name inside let function. So we gave this as our function name, And now we will define this, define a lambda for this particular variable. So we will use lambda function here, lambda, and now the input will be exactly same as that for some digits function that we declared earlier. So we will take the input as number from the user, and in addition to the inputs that we will take from the user, we will create uh, one more variable from our side, that will be the recursive function, that will stand for recursive function. So let's say we call that as rfn, recursive function. One additional input we will have to use here, rfn. Now what we have to do, we have to use the same function, exactly same function. Let's paste that here. So as you can see, if the length of number, right, this number is again the input here, num. If the length of number is equal to 1, then we want that number back. Else we wish to call rfn here, right, recursive function here. Now there is a reason that we have to use this rfn here, additional rfn here. What is the reason? The reason here is that, is some digits variable, this particular variable, is it defined already? No, it is not defined. So let me show you an illustration why we have to create or use that additional input if we are declaring recursive lambda inside let function. So why do we need that? Let's say if we are using this let function, and let's say we are using a here, right, we are declaring a variable a, and what does a do? A does that a plus 1, right, a plus 1, and as our output, let's say as a calculation, final calculation, we wish to see uh, let's say a back. This will not work, right, because we haven't declared a here. We haven't declared a here completely. If we declare, let's say, a as 2 plus 1, and if we now see the output of a, we will get 3 here. But if we use the a here when we have not declared the a variable previously, then we cannot use it like this, right? We have not declared a here. If we use, let's say, calculation as 3, we will see 3 here, but we haven't declared a here, so we cannot use it like this. First of all, we will have to define a, and then we can use it later. So here as well, the same thing is happening, that we haven't defined some digits recursive here, so we cannot use it here until here, right? In the final output also, we will not be able to see the its operation, right? So first of all, we will have to create it, define it, and then finally we can use it. So that's why we are using an additional parameter here as rfn. So rfn we are using here, and inside rfn again we are performing the same action. And what were the two parameters for this sum digits rack? These were num and rfn, right? For this lambda, num and rfn. So we will have to do this here as well. We called the recursive rfn here, and then what we will have to do, we will have to call that here as well, rfn, right? rfn, and let's close the brackets, comma. In our final calculation again, we will call some digits. What we will have to do, we will have to call that here as well, rfn, right? rfn, and let's close the brackets, comma. In our final calculation again, we will call some digits rack that we declared here. Right now we can call it, because now we have completely declared it, we have completely defined it. And as you can see that in this portion, we haven't used that same name here again, right? So we can use it here, and as our input we will pass this, comma, again that's uh, some digits recursive again, this same function again, because this is a function, and this stands for recursive function, so we will have to call that again. Let's close the brackets, let's press enter. So we got 6 as our result here as well. Let's change our input to, let's say, something else. We got 8 here directly. We don't have to go through all this process, because we don't know how many iterations we will have to perform this same task again and again, right? Let's use some other number. We got 1 here directly, right? So we have covered do until loop as well. And finally, what are the components of each of the solutions that we discussed, right? Each of the things that we covered until now. First of all, we will have to define the kind of loop that we are going to use, right? So let's say we will have to define that here we are going to use for next for each loop, then here we are going to use for next loop. we will first of all have to go through the problem, that what the problem demands from us. So first of all, we will have to define the loop. Like here, we could not say that after these many iterations we have to stop. We have to do this for 9 iterations, 10 iterations. There can be n iterations, but there is a condition attached that where we have to stop. So this is the case of do until loop. So we will have to define loop here. Then we have to define function. In case of reduce, we saw that we will need reduce here, right? There will be the need for reduce here. We cannot do it without reduce. There may be ways, but a simpler way will be using reduce. Here as well, again, we defined that we will need map function here. So we will have to specify the function that we will need, right? And finally, what is the common action that we are performing? It was again common across all that we have discussed until now. This was the common action, right? This was the common action that we performed, let's say here. And let's say in case of recursion as well, we this was our common action, base function, right? So we have to define the base function. We have to filter out the function that we are going to use, and we have to also specify the kind of loop that we are going to perform, right? So this was all for this Excel. And now I wish to share the presentation for the infographics for each of these Lambda helper functions that I have prepared. So I think I will have to share it again. So I will stop sharing and begin share. Okay. So we saw the application for by row with the help of infographics. So let's say this is our input array of all the ingredients, different ingredients that we have. Let's say we have flour, we have sugar, milk, chocolate, and eggs. Now for each of these rows, we have to bake them together. We have to mix them together, and there will be some output. If we mix all the items of, now tell me, what is the size of this input array? It is 5 rows, 5 columns, and 3 rows. So the final output will be of, again, 3 rows, because input array has 3 rows. So in total we will generate 3 items, right? And for each of these rows we have to mix them together. So we will get the output as cake for the first row. For the second row we will get, let's say, tea as the output. For the third row we will get sandwich as the output, mixing all these ingredients row by row, right? Row by row we are mixing these ingredients. And again, the size of the output and the input array, they have this relation, that the size of the output will be the number of rows that we have in the input array, and the number of columns will be 1. There cannot be more than 1 columns as a result of by row function. Okay, let's move on. By row and by call is exactly same, just inverse this, right? So by call is exactly same, just that we are performing that for each of the columns. Now for map, we are performing the same action for each of these values, right? This is, let's say, our input array. In this we have 2 columns and 3 rows, and we have in total 6 values. 2 multiplied by 3, 6 values here. And for each of the values we are performing a common action. Common action here is, let's say, we are cooking them, right? We are baking them or cooking them. So if we cook, let's say, corn, we will get popcorn. If we cook something using rice, we will get dosa, right? If we cook something using, let's say, potatoes, so we will get french fries here, and so on. So for each of these items in this array, this is the application of map function. Let's move on and let's see this for scan function. Now scan function, in a scan function, again, scan and reduce are special functions where we can store the previous results as well, and deal with them as well. So we have initial value. Let's say we start with bread. And these are the components that we are going to use. This is our input array. So we use butter first. We mix bread with butter. We get this as our output, right? Butter applied on bread. Then next input will be this bread butter, and on this we apply cheese. And we got our result as cheese with bread and butter. Then our next input will be uh, but bread butter with cheese, and we apply salad on this. So we got this as our output. And finally we put them together in toaster. So we finally got the output as sandwich. Now, what does a scan function do? It stores the result at each iteration. At each iteration for this input array. So we have as our output this complete process, right? At each process, what is the output that we got? So we have stored each of these results as output of a scan. This is the utility of a scan. And if we see a reduce function, this is just same as a scan, but at the end what we are getting as output only the sandwich. We are not storing each of the intermediate steps or intermediate outputs that we are getting. We are just getting the final result, that is sandwich. Here we started with bread, we applied butter, then we applied cheese, salad, and baked them together inside toaster. We got finally the output as uh, sandwich. So this is how these lambda alpha function works, and that is it from my side. So that is it from my side, and I can stop sharing.
Yes.
Okay, so these are one dimensional. Okay, so we have different concepts of arrays inside Excel. We have got lifting, then we can use pairwise lifting. This is again another concept. And then this is broadcasting. Let's say this is first array and this is second array 10, right? uh, First array of different numbers 10, 20, 30, 40, 50. We map them here, right? We wrote them here one by one. Then in the second array by which we are dividing it, we have only a single number 10 here, right? This has 5 rows and this has only a single row and single column. So what it will do, what broadcasting will do, that it will create a virtual array so that the size of both the arrays are equal. So the size of this was 5 rows, the size of this was only 1 row. So it will broadcast the previous, it will broadcast this 10 to 5 rows. So the size of this will become 5 rows, and in each of the rows 10 will be populated. So 10 by 10 will be 1, 20 by 10 will be 2, right? This is a virtual array. These are additional values that broadcasting generated for us. Then let's say we have second example where we have, let's say, 5 rows in first array and only 3 rows in second array. Now Excel got confused, or let's say broadcasting will not work here as we thought of, because now for this, let's say for the fourth row, we have got 3 options to populate. We can populate out of these 3 options here. So it got confused. It cannot decide that which out of 3 we should publish here. So we got NA here, right? Extra values. The size of both the arrays will be same, 5 and 5. But that extra row, that will be populated with NA error. Why? Because it cannot decide that out of these 3. And again, in output as well, if we divide these by these corresponding values, we will get values and NA errors here. Here it was able to decide that, okay, there is only one single value, so we will populate 10 in the additional rows. One more example of this can be, let's say, this one, right? Let's say this is array 1, this is array 2. Now array 2 here is, let's say, 2 columns and 3 rows, and here it is 3 columns and 1 row. So what it will do, virtual array, we will create one virtual array which will be of size how many? Maximum of number of columns is 3 columns and 2 columns. Maximum is 3 columns, and maximum rows is again 3 rows. So 3 rows and 3 columns. This will be the size of the resultant array, right? This is the resultant array, and this is the virtual array. For both, it will create virtual arrays. For both the arrays, it will create virtual arrays based on the number of based on the maximum number of columns and maximum number of rows across all these arrays, virtual arrays, and then finally this resultant array. So in this resultant array, for the final column, we have these NA errors, again due to application of broadcasting.
I don't see another question. Maybe for me, before we close, is how do you know all this? How do you study for you to get where you are? What method do you use to know all those functions and all those capabilities?
So again, what helped me more is my understanding of loops inside VBA. So initially I started with VBA learning before Excel 365 was released. I had learned loops inside VBA. So that kind of mindset helped me a lot in understanding these new functions. So I went through the documentation, and my process is that I always read the description of each of these functions. So let's say we went through the descriptions of each of those functions as well. What does map function says? What does uh, by row by call, each of the functions tell to us. And I saw various YouTube videos of other channels as well. I learned from them. Then for practice on LinkedIn, several challenges by excelbi and other persons are posted, so that helps a lot in understanding and creating more clarity. So
Okay.
defining patterns, making patterns, and breaking down the problems into different uh, breaking down the problems into different rows, different columns, like that.
Okay, that's
So
interesting.
that is the process.
And then maybe the last question is that do you have a paid course or something that people, if people want to learn from you, do you have anything recorded or do you offer training?
Yeah, I offer a training on again these functions, all these functions, but that is in Hindi. That is not in
Okay.
English language. That is in Hindi, and I have until now recorded approximately 50 hours of content, 50 hours of videos. I
Okay.
have recorded that, and that is now what I'm taking it currently live, and recording it, so that if any case, in case any Hindi viewers wish to get, they can see the recordings later. And I am again covering all these functions in that course, that paid course, all these
Do you have,
new dynamic array functions, lambda functions, and all.
okay. Do you have a link to your tutorial so that you can share on the chats, or maybe you can share it with me and then I'll share with every other person so that they can come and know more.
Yeah, sure. So let me do one thing. I will share it right away in the
Okay.
chat. So
And are you planning to do one in English?
yeah, I am planning to do, once I'm done with, let's say, this Hindi version. I'm making it, I'm trying to make it as comprehensive as possible. Whatever I can give out of myself, I will try to first incorporate in this Hindi course, and then I will try to make a same version of English course as well. So that's why. Mm, just a second. So this is the link I've posted in the comments below, chat section. Mm.
Thank you for honoring the invite. Um, more followers and more students to train. I'm looking forward to the English version. So please update me when it's out. I'm more and ready to come and support and also join you. And
Sure.
yeah, and I think that's it. Unless you have something else to add, I think we are done with the first webinar, the very first one. And thank you for making history and looking forward to many more.
Yeah, sure. So thank you for inviting me. It was a pleasure to present here. Right. I also learn a lot from this community, and I learned a lot from your blog, your videos as well. So thank you for
Okay.
inviting me here, and anytime more than happy to contribute in future as well. Yeah, in any way I
Okay.
can
You're
do.
right. Okay. So we are done with the webinar for today. So see you in the next 2 weeks. Bye.
Right.